Okay, so again, I asked you to distribute out these what are called perfect square binomials. Okay, so I'll just show one more. Remember, the exponent outside of the parentheses affects the whole thing. So we need to write the whole parentheses twice. And then to multiply it out, we can draw a 2 by 2 box. So x plus 7 over here, and this one is also x plus 7. So x times x is x squared, x times positive 7 is plus 7x, 7 times x is plus 7x, 7 times 7 is plus 49. Okay, so the four boxes are x squared plus 7x plus another 7x and plus 49. So at the end, that gives us, these two can combine. So x squared plus 14x plus 49. Okay, and I'll put the final answers only for the last two. So it's important to have these four sort of examples, because as we've done many times, we're going to try to now find a pattern that will make sort of future problems easier. Okay, but first let's define some vocabulary. So I gave you this phrase up here, perfect square binomial. Okay, so if you break it down, these are all words we've heard before, but maybe not together. So the binomial part, we remember that means there's two terms. So if you look right here, there's two terms, right? X and -3, or here, X and positive 7, and so on, X and -6. Okay, so that's why it's a binomial. And then the square, we say like x squared is x to the second power. So that's where the square comes in, right? All of these were to an exponent of 2. Okay, so a perfect square binomial. Okay, so the way we'll use it, so it's going to be a 2-term polynomial in parentheses. All right, so that's the binomial part. And then now for the square part. Okay, so these things called perfect square binomials can be useful in our goal of solving equations with x to the second power. Okay, so now again, we had 4 warm-up problems. Let's try to find some patterns. Okay, so like this left problem, remember the initial problem, the perfect square binomial was parentheses x minus 3 all squared. And we calculated that this is equivalent to the trinomial x squared minus 6x plus 9. Okay, and then similarly, this one multiplied out to here, and x minus 6 all squared became this. Okay, so I want us to take a look at, again, all 4 problems and see if there's any pattern between the left side of the equal sign and the right side of the equal sign. Okay, is there something you notice that is always true, no matter which of the 4 examples, it's true for all of them? Okay, so let me just give everyone else a few more seconds to think. Thank you for raising your hand. Okay, so I'll be looking for 2 patterns. All right, so even if a classmate gives one correct answer, there's might be another one out there. Okay, Rustam, do you want to share one pattern, and then I'll go to Julie next?
Okay. One of the patterns is the coefficient at the end for each of the problems is squared. Like, for example, for the first one, so -3 squared is +9.
Okay, true.
7 squared is 49. -6 squared is 36. And 10 squared is 100.
Okay, perfect. So he showed that for all 4 problems, so again, we gotta use some vocabulary here. So the number inside the parentheses, squared or times itself, always equals the constant, right? The term without a variable. Okay, so that's one good pattern. Okay, so again, you take this -3 in parentheses, you multiply it by itself, -3 times -3. That gives you the +9 constant. Okay, and you take the 7 in the parentheses, 7 times 7 gives you the 49, and so on. Okay, and then Julie, did you have the same pattern or a different one?
I noticed that like the number in the parentheses,
Yes.
if you add them with like itself,
Uh-huh.
then it adds to the second number.
Okay. Sure. So she noticed that, let me erase the red for a second. Okay, so she noticed that if you take the that same number in the parentheses, but this time instead of multiplying it by itself, this time she said you add it to itself. So -3 plus -3, or if you add to it yourself, you're multiplying by 2. So -3 times 2 equals -6, right? And +7 times 2 is +14. Sorry, I erased too much. This was originally 6. Okay, so -6 times 2 is -12, and +10 times 2 is 20. Okay, so great. That's another important pattern. Okay, so again, she said added to itself, which is correct, but I'll just phrase it as times 2. Okay, so, and then when she said the second term, that's always the term with just the regular x, right? Not the x squared and not the constant, but just with the regular x. So I'll say it equals the coefficient of the x term. Yes?
When you said times 2, but like was -3 for the first problem?
Yes.
-3 times -3 times 2. Oh,
Yeah, so we don't want to mix up the two patterns, right? So the first, what you were about to say was what Rustam said the first time. So yeah, both of you are correct. So they're two different patterns. Okay, and I had a student in the chat say one more thing. He said that when it's adding, so like when it's adding like in this problem, the trinomial will always be all positive. There's no negatives at all, right? We saw that over here also. Okay, so that's another cool pattern that's important to recognize. Oops. Okay, so the two patterns that I wrote down here, though, are the ones that will help us with this next section. Okay, well, we can actually use the third pattern as well. Okay, so looking at this top left problem, we have two different blanks, right? A blank on the left and a blank on the right. Okay, so you need to fill them both in so that the two sides are equal. Okay, so this might sound pretty tough, but using the patterns we just figured out together, we should be able to do it. Okay, so any ideas where to start? Again, it's got to be based on the patterns we just found. Go ahead, Rusman.
Since they given the middle term,
yes,
just 10x. To get the number on the parentheses, we could divide 10x to get the answer to the binomial.
Yeah. Okay, very good. Good use of vocabulary. Okay, so we're actually sort of using the pattern backwards, right? Because in the original problem, we were looking at the -3, and we said -3 times 2 equals -6. But it might be more useful to think about it backwards, right? We could say, okay, if we started by knowing the -6, then we divide it by 2 to get to the -3. Okay, so if we want, we can reword it. It means the same thing, but we'll probably use it more in this direction. Okay, so I'm gonna rewrite the bottom rule, but sort of in the other direction. Okay, so hopefully you can read that. It says, divide the coefficient of x by 2 to get the number in the binomial. Okay, so again, what Rustam did here was he took the 10 and divided it by 2, and that equaled +5. Okay, and this fits with the pattern our other classmate said, right? He said that when it's positive in the parentheses, it's all positive on the other side, and that does appear to be true. Okay, so now maybe for this one, I'll see if anyone who hasn't shared yet thinks they know. So can we figure out the other blank then, now that we know that the number in the binomial is a +5, Daphne? Good, and how did you figure that out? Okay, good, so this time she used the first rule. Now that we know the number in parentheses, you times it by itself to get the constant. Okay, so again, one more time what we did, we took the 10, the coefficient of the x, and we divided it by 2 to get 5. By the way, a mistake I've seen a lot in the past is people want to put 5x here because they do 10x divided by 2 is 5x, but that's not correct. Again, you're only taking the coefficient, so you're not keeping the x with it. Okay, so we took the 10 divided by 2 gave us 5, and then we did 5 times 5 to get this 25. Questions?
Just by that logic, does that mean for the last one, does that mean that,
sorry, by last one, do you mean top right or bottom right or bottom right?
Does that mean decimals are going to be at
yes, so Thomas noticed that for some problems, decimals or fractions will be created. Okay, so please see if you can fill out the other 3 boxes in this section. And of course, we can always check our answers ourselves by multiplying it back out. Okay, so I just quickly checked my answer for the top left problem. Again, I think the answer, one of the answers is this. So I went ahead and multiplied it out just like I did on the warm-up, and I did end up with the other side. All right, so that's how I can know my answer is correct. Okay, so hopefully what you did for the top right problem is first you would divide the coefficient of x, so the -8 by 2, that gives you -4. That goes in the binomial in the parentheses. Then we take that -4 over to the other side and we do -4 times itself. So -4 times -4 is +16. Okay, bottom left. So this time we take the -2, divide it by 2 to get -1. Then we take that -1 over to the other side, multiply it by itself. -1 times -1 is +1. Okay, and then again, as our classmate mentioned, sometimes fractions or decimals are unavoidable. So we do have to deal with those sometimes. So in this case, the coefficient is 5. So when we divide 5 by 2, we get either 2.5 or you can keep it as the fraction 5 over 2. Okay, so we take that 2.5 over to the other side. Oh, sorry, not plus, times. And we still multiply the 2.5 by itself. But again, this one just takes a little bit more calculation. Okay, so if you don't have a calculator with you, just remember that after you do the regular multiplication, you need to count up how many spaces are behind the decimal points. In this case, there's 2 spaces to the right. So we need to go in 2 spaces to get our answer. Okay, so this will be sort of 2 steps in a longer process called completing the square. This will sort of show up in the middle, but I think it's good to look at this part first. So do we have any questions about the way we can figure out the number in the parentheses and then the constant? All right, so in that case, let's go ahead and move to the next page.
I had a question.
Oh yeah, sure.
Is it ever possible for the last coefficient to be negative?
So this spot right here?
Yeah.
Okay, good question. So in case you guys didn't hear, the question was, well, if you didn't notice, like I already printed the plus sign in for you, right? So the question was, is it possible for this blank to ever be negative? Does anyone think they know the answer? Yes, it is. So what would have to be on the right side in order for there to be a minus over here? Okay, so Rustam thinks he actually figured out his own question. So why do you think it's not possible?
Because when you square it, like it's always negative times negative, positive times positive.
Right.
It's never negative times positive.
Okay, very good. He said, if this number is negative, you do a negative times a negative, which gives you a positive. Or if this number is positive, you do a positive times a positive, which is still positive. Right, so you'll never have one positive and one negative. So this number will always be positive. Okay, so good question, and I'm glad you were able to figure it out. Let's go ahead and move to the next section. Okay, so what we're going to do here is we're going to sort of solve two problems side by side, and then, or I'll tell you the step and I'll demonstrate it on the left problem, and then I'll have you guys try that on the right problem. Okay, so we're just going to go sort of one step at a time. Okay, so the two functions we're going to work with. So on the left, let's say that we are going to try to solve 2x squared minus 8x minus 26 equals 0. Okay, and then on the right side, why don't we do 3x squared plus 6x minus 11 equals 0. Okay, so again, these are two separate problems, but we're going to sort of bounce back and forth between them so that we can hopefully get practice doing one step at a time. Okay, so real fast, why do we need a new method, right? Why can't we just stick with last class's method? So don't write this down, but let's say that we did try to factor the left side. Again, don't write this down because you need all the space you can get. But we would try to factor it like this, right? We would put the 3x squared here, the minus 11 over here. So the missing two boxes have to add up to 6x and multiply to 3x squared times 11, which is negative 33x squared. Okay, so what are the ways to multiply to negative 33? 1 and negative 33. 2 doesn't go into it. 3 times negative 11. Then nothing else works until 11 and negative 3, and then 33 and negative 1. Right, so these are the only ways to multiply to negative 33, but none of them add to 6. Right, this adds to negative 32, negative 8, positive 32. None of them work. Okay, so last unit we would have said this is unfactorable, and we would have stopped there. But now we're learning that there's a way to continue on with this problem. Okay, and again, that method is completing the square. Okay, so factoring is very nice whenever it's possible, but for all the problems where it doesn't work, we can do completing the square instead. Okay, so let's write down the first step below. Okay, so this one's already done for us. Okay, so maybe you remember last class, some of the problems look like, find the roots of f of x equals, some function. Okay, so what we did in those problems was we set it equal to 0 because that's what a root means. It means you want the y value to equal 0. Okay, so the two examples I gave you, they're both already equal to 0, right? So we can sort of skip that step. Okay, so second step. Okay, so what we're going to want to do is we're going to want to move the constant to the other side. Okay, so basically we want the constant by itself. Okay, so you see in the left problem, the constant, the negative 26, is not by itself, right? It's with all the other stuff. So to get rid of the minus 26, we would add 26 to both sides. Okay, so now let me ask you guys to try doing that same process for the problem on the right. Okay, so again, the numbers are different, but do the same goal, which is get the constant to the other side.
I forgot how to do a last class.
Well, last class we would have factored instead, but I showed earlier that this is not factorable. There's no combination of terms that would.
I get what we're doing.
Okay.
I just forgot how to do what we did last.
Oh, okay. I'll go over that in a bit then, but let me finish this one first. Okay, so in this case, you would want to move the 11 over. So you would add 11 to both sides. Okay, so hopefully this is what you did for your next step. If not, please fix it. Okay, so third step, we're going to factor out the coefficient of x squared if it's not 1. Okay, so when we say factor out, that's going to be similar to the factoring by GCF, which we learned last unit. Okay, so for the left problem, again, you look for the x squared term. The coefficient on that x squared is a 2. Okay, so I'm going to factor a 2 out. And so remember, when we move that number in front of the parentheses, we have to divide everything else by that number. Okay, but we only do it to the things on the left side. The 26 on the other side is not affected by this. Okay, so let's go ahead and do some simplification. 2x squared divided by 2 would just become regular x squared. Okay, and then negative 8x divided by 2 would be minus 4x. And again, the right side is unaffected. We haven't done anything to it yet. Okay, so again, when you're ready, go ahead and try doing the similar step for the other problem. And those of you on Zoom, since I can't see your work, I'll ask you to type me what you get. Let me take a quick look around how you guys are doing here. So we're not factoring what we did. Good question. We're not factoring out the GCF like we did last unit. We want it to remain an x squared. So even though it's possible to take out more, in this case we choose not to. Okay, so I just got asked a good question. The question was, how come we don't also factor out an x? Because they do have an x in common. And that would be correct if the instructions were to factor by GCF or greatest common factor. But this time we do not want to factor out the x because that would not help us achieve our end goal. So we always only factor out the coefficient for this method of completing the square. Okay, so what we should have gotten is 3 times parentheses x squared plus 2x and then equals 11. Okay, so now for the next step. So the reason it's called completing the square is it usually doesn't start with it already being a full square. We need to complete it by adding in a missing term. Okay, so the way we can visualize this is, so we're going to put a blank in the parentheses and on the other side. Okay, so what I mean by that is over here. So in this parentheses, I'm going to put just a blank because I'm going to have to figure that out later. And then on the other side, I also put a blank. Okay, so, this one over here, I'll just go ahead and do. So the only thing I'm doing at this step is putting in these 2 blanks, one in the parentheses and one on the other side of the equal sign. Okay, so the kind of confusing thing is we're going to leave these blanks for a bit and we're going to jump down to the next line because we actually, it's easier to jump down a step and then go back. Okay, so what are we going to do here? What color haven't I used yet? Blue. Okay, so here are some of those vocabulary words we went over earlier. So remember, trinomial is 3 terms, right? So the blank is included. The blank represents something. So this thing in parentheses is 3 terms. So we're going to rewrite this as a perfect square binomial, right? So we're going to take the current parentheses, which has 3 terms, and rewrite it so there's only 2 terms. But remember, perfect square means there's a squared on the outside. Okay, so now how do we figure out what goes in that binomial? Well, this is one of the patterns our classmates helped us with earlier. All right, so if we look back at this problem, let me erase some of the work. All right, so this is basically what we're trying to do on the next page, right? So if we pretend that instead of being sideways, I wrote it down here, right? Okay, so right, this is what we're trying to do on the next page. So the pattern our classmates told us was you take the coefficient of the x and you divide it by 2 to get that number in the binomial, right? So for this problem, we did -8 divided by 2 is -4, and that's how we know a -4 goes in here. Okay, so okay, so again, I know that's a lot of words, but you guys did very well on this earlier. We just now need to see how that first page is connected to this page. Okay, so over here, so it always starts with x in the parentheses, right? That's what we noticed on the previous page. But then this number in the binomial, again, is always half of this, or this divided by 2. So -4 divided by 2 then would be -2. Okay, so see if you can do the same thing to the other side, please. And again, those of you on Zoom, if you could let me know what you get. You're done. Thanks for being patient. Let me just quickly check out 1, 2. Okay, so again, we're looking at the coefficient of x, which in this case is +2. So we divide that by 2 to get +1. Okay, so again, let's go back to the beginning page and remember what we did. Okay, so what we did for this problem was, well, let me leave that. So after we figured out that you divide the -8 by 2 to get -4, right? The other pattern was that if you multiply that number by itself, that gives you the constant, right? So over here, what we did was, okay, we did -4 times -4 to get +16, right? And as Rusta mentioned, this number is always positive because anything times itself is positive. Okay, so let's see, Brown. Okay, so now that we've figured out what goes in the perfect square binomial, we can go back up a step and fill in one of the blanks. Remember, we created 2 of them. So we're going to fill in the blank that was in the parentheses. Okay, and again, that number is always this constant that we just figured out times itself. Okay, so I'll just say squared, right, times itself. Okay, so for the left problem, again, the binomial number is the -2 that we just figured out. So to go back and fill in the parentheses blank, we have to do the -2 squared, right? Or the -2 times itself. Okay, so that would equal a +4. Okay, so go ahead and fill in the similar step on this other problem, please. Okay, so hopefully what you did is you looked at the +1 on the step below and you said, okay, what is +1 squared? Well, +1 times itself is still +1. All right, so in this case, this blank is filled in with a +1. Okay, so we filled in one of the two blanks, right? But there's one more blank to go. Well, let's just think about any equation, right? So quick side example, you don't need to write this, but you know, for something like x minus 3 equals 5, we're allowed to add 3 to the left side as long as we add 3 to the right side, right? You're allowed to do anything to equation as long as you do it to both sides. So in this problem, right, comparing these two lines, we just added a -4 out of nowhere, right? It did not exist on the previous step, but we just squeezed it in. So because we changed the left side, we need to change the right side by an equal amount. Okay, but the equal amount is kind of tricky. Okay, so let's see. Let's use gray. Sorry, I'm out of room. I'm gonna have to go down a step, so I'll move step 8 down. Okay, so again, you might think, well, shouldn't we just add the same number to both sides? Well, sometimes, but sometimes it can be misleading. Okay, so if I go back up here, so when it looks like I added 4 to the left side, right, that brown number, I really added more than 4, right? Because this +4 is affected by the 2, which multiplies the entire parentheses. So I really added 2 times 4, I really added 8. Okay, so on the other side, instead of just adding 4, I have to add 8. Again, because this 2 affects the 4 that I squeezed in. It's actually gonna be more, sorry. Because I realized as I was doing this, it makes more sense to split something up. So I'll have to add on to the bottom. Okay, so if you haven't already, go ahead and figure out the right side, please. So what goes in that other blank?
You were gonna do the opposite of section.
No, we do the same operation to both sides in order to, I think I erased it. But for example, if I had like x equals, well, x minus 3 equals 5. So to solve it, you would do the opposite of the minus 3, right? You would plus 3. But what you do to both sides is you do the same thing to both sides. Yeah, so sorry, that's what I meant. Okay, so good. Those of you who I checked were able to see that this plus 1 is also affected by the 3 in front. So 3 times 1 means you actually added 3. Okay, and so now I'm not going to write this as a separate step below, but we need to keep everything from the rest of the problem, right? So this 2, which has been in front of the parentheses for the whole problem, it's still there. So let's make sure we keep that. And on the other side, now that we have the 26 that's always been there, and now it has a plus 8 that joins it, let's just go ahead and do that calculation. So 26 plus 8 would be 34. Okay, so same thing on this other side. We keep this 3 in front of the parentheses. And then on the other side, we'll just combine up. 11 plus 3 would be 14. Okay, so I got a question. What if there was no coefficient in the beginning? Well, in that case, there would be like an invisible 1 in front. So when you do 1 times anything, it stays the same. So we will see one of those problems later. Okay, so step 8. Okay, so we're going to need to get the parentheses by itself. Okay, so if we look on the left side, the parentheses is not by itself, right? It's got this 2 attached to it. So here is where we would do the opposite. The 2 is multiplying the parentheses. So to get rid of it, the opposite would be to divide both sides by 2. Okay, so notice the 2 only affects the coefficient. You do not divide the inside by 2. The parentheses and the exponent sort of protect it. Okay. So let's do a similar action on the other problem. So this time it's a 3, which is multiplying the parentheses. So we would have to divide by 3 instead. Okay, so I'm just going to leave the 14 divided by 3 as the fraction 14 over 3. Right, if you try to turn it into a decimal, if you grab your calculator, you would see it's a decimal that goes on forever. Right, it would be 4.66666 forever. So it's actually better to use a fraction in this case. I know a lot of times students prefer decimals, but in this case, it actually makes a lot more sense to use fractions. Okay, so again, I do need to add on to the bottom, unfortunately. So there'll actually be 2 more steps, but they're both kind of short. Okay, so now the way we get rid of this exponent of 2, so it's the operation we've worked on last unit, the square root or the radical. Okay, so I'm going to complete the sentence in a second, so there's more to it. Okay, but why is this necessary? Okay, so let's just look at a little side problem for a second. Right, so what if I told you some mystery number x squared or times itself equals 16? Okay, so 4 definitely works, right? Because 4 times 4 is 16. But that's not the only answer.
You could square root both of them.
Yes, the operation we would use is square rooting, yes. So that would lead us to 4, but also a second number. And does anyone know what that other number is that also times itself equals 16? Oh.
-4.
Okay, good. Taylor says -4. Okay, so again, a negative times a negative equals a positive. Okay, so the way we can write this is instead of saying x equals 4 and x equals -4, we can use what's called a plus minus symbol. So it's literally a addition sign over a subtraction sign, but that means both positive and -4. Okay, so since this will always be the case, that you can always get both the positive and the negative versions of the same number, we will always need to include this plus minus sign. Okay, so we're almost there. So as Rustam said, in order to get rid of the squared, we would square root both sides, right? So we draw a big square root over the entire left side and the entire right side. Okay, so what should always happen on the left side is the square root and the exponent of 2, they're opposites, right? Just like addition and subtraction are opposites. Well, just listen to the name. Square and square root are opposites. They're named that for a reason. So these will all cancel out, leaving just what was inside the parentheses left behind. Okay, but on the other side, square root of 17, 17 is a prime number. The only way to get to 17 is 17 times 1. So we cannot simplify that at all. But we do want to include the plus minus sign in front of it.
Well, technically, can't we have -17 times -1?
That's true. That's true. So I guess I should clarify that for the definition of prime numbers, it has to be, well, whole numbers are by definition always positive. So we do not consider the negatives when determining if something is prime or not. But that's a good observation. Okay, so on the other side, same thing, square root both sides. All right, that gets rid of the parentheses and it gets rid of the squared. But on the other side, we can't really simplify, so we just leave it. Okay, so now for the very last step. Okay, so this one should be familiar, right? This is what we do for any equation. Finally, we're ready to get the x completely by itself with nothing else on the same side. Okay, so now if we look over here, right, the x is not by itself. It's got this -2 attached to it. So the opposite would be to add 2. Okay, but what we want to do is the plus minus symbol should always end up in the middle of your answer. Okay, so we don't want to put the +2 over here. Instead, we are going to put it over here. Okay, so our final answer is the left side. Again, these cancel out. So we just have the x left behind. And then on the other side, we've got a +2 plus or minus, and then the square root of 17. Okay, so again, this actually represents 2 different answers. It represents 2 plus the square root of 17, and it represents 2 minus the square root of 17. So the plus minus symbol means you first do the addition, then you do the subtraction to get 2 different answers. But we can just write it with the plus minus symbol to save space. Okay, but you should understand that this is what it actually means. Okay, so just hypothetically for a different problem, let's say you ended up with 4 plus or minus 1. So you would do 4 plus 1 is 5, but you would also do 4 minus 1 is 3, right? So you would get 2 different answers. Okay. So over here, to get rid of the +1, we would subtract 1 from both sides. Okay, so this time it's -1 plus or minus, and then we have the square root of 14 over 3. Okay, so again, I know this is a super long process. Unfortunately, that's the way this method works. But step by step, I don't think each step individually is that hard. It's just remembering, what to do in order. Do we have any questions? Yes.
You just said, like, for example, if it was like 3 minus plus sine 1,
Yeah,
would give 2 kind of answers. So would we check to see which one gives the answer 0?
Good question. In theory, they should both lead to an answer of 0. So yes, you could have 2 different answers for a quadratic. Okay. Okay, so why don't we try the top left problem on the last page? Okay, so again, the steps are all here. I'll leave them up in case you want to look here instead of flipping back and forth. Or you can just, you can probably see them both at the same time with the way it's printed. But go ahead and try that top left problem and see if you can get to an answer. Okay, so feel free to let me know if you get stuck at any point, if you have any questions. So normally homeworks are due at 8:25 a.m. the day after. So the homework will get today tomorrow at 8:25 a.m. Yeah, anytime before then. So I ask you to upload everything to Canvas. So if you go to like the assignments, you'll have the option to upload a file. So you can just like take a picture of your homework and upload it there. Yeah, so just let me know if you have any questions. So yeah, remember the very first step, the one we sort of skipped for the examples, was you find the roots, you set it equal to 0. So you say 0 equals all of that. Okay, so first we jumped down to the next row and we said we look at the coefficient of x, which was -4, and we divided it by 2 to get this -2. Okay, and then now that we know this number, we multiply it by itself to get that. So let me go ahead and start this top left problem. Okay, so again, for the problems on the examples, these were already equal to 0. So I said, let's just skip the first step. But if it's phrased like find the roots or find the x-intercepts, remember the very first thing you do is you set it equal to 0. Okay, so let's go ahead and set this equal to 0. Okay, second step, move the constant to the other side by adding or subtracting. Okay, so to move that -29 over, I will add 29 to both sides. Okay, so now step 3, factor out the coefficient of x squared if it's not 1. Well, in this problem, it is a 1, right? It's an invisible 1, so there's nothing to factor out. We can still put it in parentheses if we want, but there's nothing factored out. Okay, next step, put a blank in the parentheses and on the other side. Okay, so remember, even though we just wrote the blanks, we can't solve for them right away. We need to jump down a row. Okay, so in blue, step 5, rewrite the trinomial as a perfect square binomial. And we can do that by remembering you always divide the coefficient of x by 2. Okay, so in this problem, the coefficient of x is -8. Okay, so the binomial then will be -8 divided by 2 is -4. Okay, so again, not -4x. You do not include the x, only the coefficient. Okay, so again, we divided by 2 to get from here to here. Now that we've done that, we can go back and fill in the parentheses blank. Go back and fill in the parentheses blank with the binomial number squared. Okay, so -4 squared -4 times -4 is positive 16. Okay, so now the other blank will be that parentheses blank times the coefficient in front. Okay, so this is the question one of the other students asked earlier. Well, for this problem, there's nothing in front, right? So there's nothing to multiply the 16, or technically it's a 1. So in this case, it is the exact same number in both blanks, because 1 times 16 is still 16. All right, so again, it all depends if there's a number in front of the parentheses or not. Okay, so now I can combine up the right side. 29 plus 16 is 45. Okay, so step 8, get the parentheses by itself. Well, luckily here, because there's nothing in front, the parentheses is already by itself. Okay, so I get to skip step 8. Step 9, square root both sides, including the plus and minus. Sorry, that's 45, not 4. Okay, so remember on the left side, the whole point of doing this is to cancel all of that out. The right side, we do need the plus or minus, but let's remember to last unit, right? We can simplify 45. 45 is 5 times 9, which is 3 times 3, right? So 45 is 3 squared times 5. So that means we can take the 3 in front. So 45 is equal to 3 radical 5. Try to combine what?
Because like I said, 3 plus minus square root of 5.
Oh, okay. So that's a good point. The 3 that you take in front, it goes right in front of the radical. So in between the plus minus and the radical. Okay, and then lastly, we would add the 4. So now the 4 cannot add to this 3 because the 3 is attached to the radical 5. So the 4 would go over here. Again, always leaving the plus minus in the middle. Okay, so after you get this down, you can use your device to pull up our exit ticket for today. So honestly, you might not finish the exit ticket, in which case you're welcome to continue it at home. But go ahead and start now, and then we'll see how far you can get. Yeah, it is, because when you factor out the 4, it creates a fraction. Yeah, so this one would get really messy. Oh, that's good.
Does the exit ticket close?
It won't close, so you can do it at any time, but the homework is due tomorrow morning, so obviously you'd want to do it before then, so you know which sections you're being asked to do. Okay, so as usual, it's under quizzes. Look for 3.2 exit ticket, parentheses, October 20th.
The exit ticket won't have problems like the...
Not like the fraction one, no. Go ahead. You might need to switch from the so how it usually works is okay, so like, you're going to answer this question and it'll tell you your score. So if you get question 1 right, that means you just get section 1 homework because you're going to really understand it. But let's say you get 0 question two. So I'm just going to go ahead and give a homework to everyone here because again, you might not finish the exit ticket while you're here. So in case you do not get 100%. That's fine. No, you don't need to tell me.